James Webb Space Telescope, world's most powerful space telescope that has ever been built. This telescope not only allows us to see the stars or planets, but more than that. On the other hand, this telescope allows us to see the black holes within our galaxy, and both young and old galaxies, as well as solving some of the mysteries of the universe like our solar system. So, are you excited to know more about it? Then, switch this video to full screen and watch this video till the end. Hello everyone! Welcome back to the Tech Universe. Before starting, don't forget to hit the like button and subscribe to our channel to get more updates on the space and tech world. That being said, let's begin. So, it is expected that the James Webb Space Telescope will be able to study the strangely flickering black hole at the heart of our galaxy, the Milky Way, which has proved to be elusive for current telescopes to explore. Webb will join numerous telescopes in their attempts to understand the nature of the supermassive black hole known as Sagittarius A, which flares up on an hourly basis, making it difficult to imagine. There will also be a team from the Event Horizon Telescope, EHT, working with Webb investigators. In February of this year, the EHT, consisting of 8 ground-based radio telescopes, captured the first ever image of a black hole, M87. In spite of the fact that M87 is closer than Sagittarius A, Webb officials say the Milky Way's own supermassive black hole is much more difficult to target because of its flickering nature. In late 2021, officials with the Webb Space Telescope noted that, in contrast to M87's steady core, Sagittarius A exhibits mysterious flickering flares that happen on an hourly basis, making the imaging process much more difficult. They said, Webb will assist with its own infrared images of the black hole region, providing data about when flares are present that will be a valuable reference to the EHT team. In order to cause flares, charged particles are accelerated around the black hole to higher energies. As a result, light is emitted. Webb, which was launched on December 25, is currently in the midst of months-long commissioning. We'll be able to image Sagittarius A in 2 infrared wavelengths from a perch in deep space, unhampered by the stray light of the Earth. It is hoped that since EHT is on the ground, the data collected from Webb will complement the ground-based network data and create a clearer, easier to interpret picture. Moreover, Webb and the EHT together should be able to provide a better understanding of what causes the solar flares, which could in turn serve as an information source for studying black holes, solar flares, or plasma and particle physics in general. In the same statement, study principal investigator Farhad Yousafzade, an astrophysicist at Northwestern University in Illinois, asserted that black holes could hold clues to some of these big questions. Yousafzade said, "It is obvious that we find out how the universe works through black holes." A physical black hole was discovered for the first time in 1971. The first EHT image of M87 in 2019 provided direct visual proof that Einstein's prediction of a black hole was correct, according to a press release. The team of researchers added that black holes are a testing ground for Einstein's theory and that they hope that this first collaboration between Webb and EHT will allow for more telescope time in space in the future. Moreover, one of the first studies of James Webb Space Telescope is expected to focus on finding out more about 19 nearby galaxies and how they fit into the history of the entire neighborhood. Through infrared observations taken from deep space, Webb's data will be able to add galactic information about star formation, powerful winds that blow off these stars, disrupting gas and dust, and mature stars that might be hidden within spiral galaxies. As I have already mentioned, Webb is currently in the middle of a commissioning period, where engineers are working on aligning the 18 hexagonal mirrors of the spacecraft and slowly testing and turning on the instruments. NASA has said that the work on the project has gone well so far, and they expect that Webb will begin science observations this summer. Janice Lee, Gemini Observatory Chief Scientist at the National Science Foundation's NOIR Lab in Arizona, said JWST touches on so many different phases of the stellar life cycle, all in tremendous resolution. Webb will reveal star formation at its very earliest stages, right when gas collapses to form stars and heats up the surrounding dust. Physics at high angular resolution in nearby galaxies, FANGS in short, is the project name for the multi-wavelength survey of nearby galaxies. In the program, there are more than 100 specialists worldwide who aim to study and understand the evolution of stars, from youngsters to mature stars and beyond. From the Earth, the galaxies we are considering are visible face-on and are located on average at a distance of 50 million light-years. Several observatories have already studied these galaxies, each bringing their own unique skills to the analysis. Among them is the Atacama Large Millimeter/Submillimeter Array, ALMA, in Chile, a microwave light survey of 90 galaxies, allowing astronomers to map where the molecules are present in each galaxy. As well as the Very Large Telescope located in Chile, the Multi-Unit Spectroscopic Explorer, MUSE, instrument of the Very Large Telescope, has participated in the project. In this study, MUSE recorded the light fingerprint of 19 galaxies in their late stages of star formation, when they are clear of the dust and gas that typically obscure a variety of observations. In addition, the iconic Hubble Space Telescope has taken part of the project, studying 38 galaxies in visible and ultraviolet light and supplying images of high quality. A major task of Webb's will be to look for those zones of galaxies filled with dust, which are rich in star formation, but are difficult to observe at other wavelengths of light behind infrared. According to the study, the benefits of the Webb study will include determining the age of stellar populations to build more robust statistical models of galaxy formation, as well as learning more about the role of dust when galaxies are formed. Researchers will be able to find out about the timeline of star formation and how it takes place in the context of galaxies in general with the help of this information. According to Lee, timescales are fundamental to astronomy and physics. Our goal is to find out how long each stage of star formation lasts. What might those timelines look like in different galaxy environments? We hope to find out when these stars release themselves from their gas clouds so that we can figure out how star formation is disrupted. Moreover, even though time travel is still a fantasy, the launch of NASA's new James Webb Space Telescope will allow us to peer back into time to the first stars and galaxies that formed billions of years ago. Yeah, you've heard it right. But the question is, how will it travel back in time? Well, take a look at it from this perspective. The speed of light is approximately 300,000 kilometers per second. With this speed, it will take about 8 minutes for the light to be released from the sun and to travel to us on the Earth. On a sunny day, the rays that we see are actually 8 minutes old. So we are not actually looking at the sun right now, but rather 8 minutes ago. Let us now apply this to other stars that we see in the night sky. We all know that most stars are light years away from us. Light years are defined as the distance that light travels in a year, which is 946 trillion kilometers. Taking into consideration that our nearest star, Proxima Centauri, is only 4.2465 light years away, the light from this star is actually a little more than 4 years old. It is estimated that many of the stars that the JWST telescope will study are tens of millions of light years away. It is likely that if we were to stand on a star 65 million light years away and look down upon Earth, we would be able to see dinosaurs through a telescope. But how far back in time will the James Webb Telescope be able to see? Well, as all know, JWST is the most powerful telescope that has ever been built. Due to its technological advances, like gold-plated mirrors and a huge sunshade, it can detect the very first stars and galaxies. Using this, we will be able to get a glimpse of how the universe looked after the universe was created around 13.5 billion years ago. Yeah, pretty mind-blowing, right? Anyway, what do you guys think about this telescope? Tell us in the comments. And that's it for the day, guys. We'll see you in the next one. Until then, stay safe, peace,